Okay, this is LeetCode 5, longest palindromic substring, and the key idea to solving this problem is basically to learn how to calculate palindromes efficiently, which I guess is sort of like a dynamic programming approach because you're going to be reusing previous calculations. So let's start by looking at a brute force approach. Let's say we have A, B, A, B, A, and then let's add C, D, A. Okay, so the brute force approach would basically be listing out every substring, like so on, and then you start with C, you'd have CA, so on, and then you start with A, and then AB. So you just check like all of these, and you like keep on going down, and then you check the C, and then you check all substrings starting at the second A, and so on. And to check if it's a palindrome, you do like a standard technique of putting your pointers at the end, and then checking if these two are the same. If they are, move your pointers inwards. Check if these two are the same. They aren't, so you'd stop. And yeah, that's sort of how it would go. So the reason I'm saying this is inefficient is basically because you have repeated calculations if I look at this part. So at some point, you're going to be checking ABABA. You're also going to be checking BAB, and you're also going to be checking A. So A would be this A, BAB would be this one, and ABABA would be that. And so when you check these strings, you'd put your 2 pointers here, and then you'd move them inwards, like so. But the problem with this is sort of, these are all repeated calculations, as in, if you know that ABABA is a palindrome, then you would know that BAB is also a palindrome, and A is also a palindrome. So in that sense, there would be no point in checking these 2 things. So the idea for removing the repeated calculations is basically to start at the center and then move your pointers outwards. And this way you don't need to repeatedly calculate the substrings. So if I put my 2 pointers here, I would start moving them outwards. So A is a palindrome, so I'd move them outwards and check if BAB is a palindrome. But I only need to check this B, and this B, because I already know that A is a palindrome. So since since these 2 B's are the same, BAB is a palindrome, and then I'd move the pointers outwards, and I only need to check A and A this time, because I know that BAB is a palindrome. So since A and A are the same, it's a palindrome, I move my pointers outwards, and then this is where we stop, because C is not equal to D. And so in this way, I do not need to calculate this string AB, AC, AB, whatever. And so basically, if you just set your center at each index, you're going to find the longest palindrome that can be made at that index. So the longest palindrome that can be made here is just A. The longest palindrome that can be made at C is just no, C is a palindrome, and then you'd move your 2 pointers out, and you'd have ACA, and that would be where you stop, because there's nothing here. So you just have these numbers, so the longest one is A, and then at here it'd be ACA, here it'd be A only, this would be ABA centered here, this would be ABABA, and then ABA, A, this would be D by itself, and then A. So that's sort of, sorry, not D by itself, this would be ADA. But hopefully you're able to get the idea of because we don't need to loop through every substring, this actually turns out to be an O of n squared calculation, because if you start at each center and then you calculate the palindromes by growing outwards, it just, in the worst case, you're going to have to go through n indices here, and the time to calculate the palindrome when it becomes the largest size is going to be O of n as well, so it just becomes O of n squared instead of n cubed. So you've reduced the time complexity like so. One thing I didn't mention is that it's possible to have palindromes like even ones, so ACCA is a palindrome. And so basically how you would handle even palindromes is you'd also have to set the left and right to be 2 characters in a row. So you would need to check, so the center is A, then the center is C, then the center is A, to do the odd palindromes. But you'd also have to check AC, and then CA, and then AB, and then BA, AB, and so on, to grow the even palindromes. And so basically you're doing like 2n, you have like 2n center points, and you'd have to grow out each one with an O of n worst case palindrome, which still turns out to be O of n squared. And yeah, that's sort of not the greatest explanation, but hopefully you're able to get the idea of if you grow a palindrome from the center, you remove your repeated calculation of needing to check, like, if your smallest one is not a palindrome, like A, B, C, if this isn't a palindrome, there's no point in checking all of these A's, even if they're the same, because you already knew the center is not a palindrome, so there's no way this large string is going to be a palindrome. So that's sort of the dynamic programming part of it, is you start from the smallest one and move, solve the smallest problem, the smallest palindrome, and then you move on to biggest palindromes, bigger palindromes. But yeah, that's basically it. Just gotta learn how to do efficient palindromes.